The Ostempering process is a specialized heat treatment. When applied to ductile iron, it consists of the following. Heating the component to a suitable temperature in the range of 825 to 950 degrees centigrade. Holding the component at that temperature for a time sufficient to homogenize the structure. Rapidly cooling the part to the appropriate Ostempering temperature in the range of 175 to 400 degrees centigrade. Holding the component at the Ostempering temperature for the time necessary to produce the desired osferrite matrix and then cooling to room temperature. This can be accomplished in various types of equipment, such as this atmosphere furnace with a specially pressurized integral quench using molten nitrate nitrite salt that is non-toxic and 100% recyclable. The Ostempering cycle is affected by the component's configuration and the chemical and microstructural characteristics of the iron. Therefore, the knowledgeable heat treater provides an added benefit for the foundry, the machining source, and the end user at meetings held early in the design cycle. By quantifying, testing, and establishing the correct material process combination for the specific product, the optimum process and property results are achieved. Using specially designed equipment and advanced process control techniques, the heat treater assures lot-to-lot consistency of the product and delivers the desired high-performance properties of the material.
Lighter, stronger, and tougher performing metal components. Focusing on Ostempering and Martempering metallurgical treatments for iron and steel, our processes improve metal at the microstructural level, providing our clients with the very best.
The Ostempering process is a thermal process that is designed to take a part, heat it up. Once you get it thoroughly heated, you bring it down very rapidly to a temperature just above the martensite start temperature. At that point, you cool it for an extended period of time, which serves to minimize the dimensional distortion that a typical quench and temper operation yields. You are able to achieve approximately twice the strength level in the iron for a given level of ductility than the historical ductile iron grades. This also yields a higher wear resistance in the material. You can decrease the weight of a part by approximately 10%.
The Martempering process is similar to conventional processes in heat treating, with the exception of we'll heat to austenite, and then we'll cool rapidly to a point above the martensite start line, hold it there until the surface and core both reach equilibrium temperature. Then we'll cool it down from there and temper as we would conventionally heat treating component. The Ostcarburizing process is similar to carburizing and hardening in that we carburize in the atmosphere at a high temperature, and then we quench it to a point above the martensite start line. And this is an excellent process for use in high load, low cycle properties. So typically in a conventional carburizing process at say 56 or 57 Rockwell C, you'd have an impact strength of about 4 to 6 foot-pounds. In the Ostcarb process, we can have impact strengths upwards of 300 foot-pounds.